Inclusive Titration's mobile technology for students with visual impairments. Presentations by Mariana Cardona Hinao, subject Analytical Chemistry. A free Android application called Titration ColorCam enables students with color blindness or visual impairments to perform titration through a multisensory experience. The app uses the phone's camera to detect the color change during titration and converts it into beeps and vibrations. This allows students to identify the endpoint without having to see the color. This technology represents a significant step toward a more inclusive science education, promoting autonomous, safe, and effective participation of visually impaired individuals and laboratory activities. Educational inclusion, volumetric analysis, visual impairment, high school, minorities in chemistry, HSB. Chemistry is a highly visual science. Many practices, such as titration, require observing a color change to identify the endpoint. This presents a challenge for students with visual impairments or color blindness who must rely on classmates or teachers. Although adaptations exist, such as olfactory indicators, they do not always promote autonomy. With the rise of smartphones, there is now the possibility of using apps that transform those visual changes into sounds or vibrations, allowing active participation. Titration ColorCam was designed precisely for this to assist students with visual limitations, so they can perform titrations independently, accurately, and safely using the phone's camera as an analysis tool. General objective: to promote inclusive science education through mobile technology adapted for people with visual impairments. Specific objectives: to explain in detail how the Titration ColorCam app works, to clearly show how it detects the endpoint in a titration, to analyze the pedagogical, emotional, and practical benefits for students with visual impairments. App operation scheme. 1. The user downloads the Titration ColorCam app on an Android phone. 2. The type of indicator is selected, for example, phenolphthalein. 3. The camera is positioned in front of the flask. 4. The app takes color samples in real time. 5. It converts that color into HSB format, use saturation and value. HSB is a color model that represents colors as perceived by the human eye. It is based on 3 variables. U. It is the type of color and is measured on a 360-degree color wheel. For example, 0 degrees red, 30 degrees orange, 60 degrees yellow, 120 degrees green, 180 degrees cyan, 240 degrees blue, 270 degrees violet, 300 degrees pink, 360 degrees returns to red. Saturation. How pure or intense the color is. 0% is gray, no color. 100% is the most intense color. Value. How light or dark the color is. 0% is black, 100% is the brightest color. This allows the app to identify with much greater precision when a specific color change occurs, such as when a solution turns pink with phenolphthalein, which usually falls between 90 degrees and 310 degrees of U in the HSB model. The app compares the detected color to a specific pre-established range for that indicator. For example, in a titration with phenolphthalein, the system expects the color to change from colorless to light pink. This change is represented within the HSV model with a U usually between 290 degrees and 310 degrees. When the detected color approaches this range, the app emits an early alert with a short beep, indicating that the endpoint is near. If the color remains stable within that range for several seconds and with enough saturation and intensity, the app confirms that the endpoint has been reached by emitting a long beep and continuous vibration. If the color enters that range, multisensory signals are activated. A short beep if the color starts to change, a long beep and continuous vibration when the endpoint is confirmed. In the following images extracted from the article, we can observe progressively how the app works during the titration process. Figure 1a shows the initial interface of the app before starting the titration. The camera is focused, but the characteristic color of the endpoint is not yet detected. Figure 1b illustrates the moment when the expected shades begin to appear. Here, the app emits short beeps and soft vibrations as an approach alert. Figure 1c shows that the color has fully entered the defined HSV range. At this point, the app emits a long beep accompanied by a sustained vibration, indicating that the titration endpoint has been reached. According to the table included in the article, the Titration ColorCam app has been tested with the following indicators, each one corresponding to a specific type of titration: phenolphthalein acid-base titration, bromothymol blue acid-base titration, eryochromum black complexometric titration, starch redox titration, methyl red acid-base titration. The Titration ColorCam app represents a significant breakthrough in inclusive science. It allows students with visual impairments to perform practical laboratory activities such as titrations independently and with reliable results. This type of technology empowers students and allows them to experience the science actively, not just as observers, which is essential for truly equitable education. Students with visual impairments were able to detect the endpoint without help. The accuracy was comparable to that of students without disabilities. Confidence, active participation, and independence increased among students. The system responded appropriately to different indicators: phenolphthalein, bromothymol, blue starch. In the context of analytical chemistry, where visual observation has historically been essential, the Titration ColorCam app allows us to rethink access and participation for students with visual impairments. Its use goes beyond the laboratory. It promotes a culture of inclusion in science. The results show that with proper tools, students who were traditionally excluded can perform with accuracy and safety, developing technical skills, increasing their self-esteem, and being recognized as active participants in educational processes. The testimony of one student who benefited summarized it clearly: "I never felt capable of doing titration. With this app, I was able to do them by myself. It was an exciting experience." Inclusive science is more than a trend, it is a necessity. This tool marks a step in that direction, opening the door to more innovations that allow everyone to learn by doing, regardless of their visual limitations or their barriers. The Titration ColorCam app is a powerful tool that transforms a visual limitation into an opportunity for inclusion. Its use in analytical chemistry shows that technology can support multisensory learning and improve equitable access to lab practice. It fosters autonomy, reduces third-party dependence, and enhances students' motivation. Additionally, it allows more students to engage in scientific processes in a deep, practical, and precise way. This approach can be replicated in other analytical techniques and lay the foundation for truly universally science education.